All right, everybody, let's welcome the team presenting and teammates to go ahead and introduce yourselves and then start telling us about your project.
I'm Todd Quist.
I'm Nick Tahero.
Tim Erickson. And this is Raise the Drawbridge.
Mm-hmm.
So, exactly. So the whole point of this is we have a vehicle that's traveling underneath a bridge that's, imagine carrying something large and will run into the bridge. And the job, what we wanted was for a switch or something to detect it, stop the vehicle, raise the drawbridge, then the vehicle can continue on its way safely to the other side, and at a certain point in time, it will lower the bridge again, and we do this, and we have this going, a there and back kind of situation. That's the goal.
Okay, so go ahead and explain your hardware.
Okay, so we have multiple types of hardware. We are using proximity switches at the very end of the tracks, and that's just for parts detection. We have magnets on our the train itself, so it'll see it better. We also use photo eyes, so we use that as visual detection. We just want to use different types of switches, and then also on our bridge itself, we are using limit switches as an in stop to prevent the bridge itself from over traveling one way or the other. It'll cut off the motor that's inside.
Mm-hmm.
And yes, we also have regular push buttons and selector switches, and other hardware that we're using. We're using 24-volt LED switches. We're using, for our train track, we're using 18 volts. 18 volts to our rail. Our motor is got 6 volts attached to it.
That's the motor for the bridge?
Motor for the bridge, yes.
Okay.
And that was one of the biggest issues, was getting all of the components to work together cohesively with all the different voltages, and figuring out how to drop the voltages down with a single 24-volt DC supply. Todd, you can talk a little about that.
Sure. We have
Talk to us.
as much as we can. We're trying to use 24-volt equipment, but in places where we need like 10 volts for the Arduino, we're using a voltage pull down to convert from 24 volt to the 10. Also for the bridge, we've got another one that goes to 6 volt, so that we don't have to have separate power supplies.
Okay, cool. Give us a demo of how it works one time around, and then we can break down the different parts of its control.
Okay. So we just turn this into auto and hit the, and this is, so that was the cross match.
This will be the time.
Exactly.
You sure it's going high enough?
Well, very
Yeah.
tall objects.
Yes, yes. Nice.
We have our crossing arms waving at the people, oncoming traffic.
Make sure they're focused.
we saw
That's
that.
intentional.
Mhm.
Very, yes. It's supposed to be like that.
Is that what that is? Okay.
Yes, yes.
And now the return trip.
I guess we could have made it a little bit of a shorter track.
Well, yeah, we
Yeah.
could have, but we imagined that it had a little tall mast, big antenna.
Originally, this was going to be a boat traveling underneath, but
Mm. The river would have been interesting to
yeah, that would have been a
Yeah.
containerize.
yes.
Yeah, that would have been hard, yeah. Maybe just get it like a big bucket.
So nice, one button does everything. One button initiated the train to start moving. Go ahead and explain the rest. As the different steps happen.
Oh, so pretty much, we have a starting requirement, of the train. It has to be in location, and the bridge has to be down. We've gotta be in automatic, and then we have we had to program a toggle switch. This is just a normally momentary, start push button. So we had to do a toggle switch in the program itself. Then the rail gets energized to a forward command. It goes all the way up until it hits this first proc switch, where it's then, the program tells it to stop.
And that's a proximity switch?
No, this is a photo eye right here.
Photo eye, there,
This is
okay.
a photo eye, yes. We had to do something special for that, but it sees the photo eye, it stops the track, it energizes our railroad crossing lights.
Yes.
It also energizes, the little, ice cube relay, control relay, just for that little sound like you hear at the,
Oh, click
Tick-tock
button,
noise,
yes.
yeah.
Very nice.
And then we have a contactor, to raise the, to give power to the, motor.
And we decided to use contactors instead of just simple control relays because although we could have used regular control relays, the contactors are what are used in industry to control larger voltages and currents.
Nice.
So we threw that in there to simulate it and to get the ka-chunk of the
Mhm.
contactor.
Yes.
Make it-
A little more for effect.
The theater.
Yeah.
Mhm.
So that's why you see those two large contact relays over there. Contactors.
And then once the drawbridge is raised, it hits the upper limit switches. Then it'll remain raised until the train travels to the second set of photo eyes. Then we have it on a timer circuit to then to lower it back down. Then it goes to its final destination, stops here, waits for the bridge to get back into the resting position, and then goes in reverse, does the same thing.
A lot of conditionals.
Yes.
A lot of conditionals, good.
Yeah, that's for sure.
If not
we
this,
bit
then
off a
something.
little, you know, at the beginning, it seemed a little simple, wasn't gonna be that complex, and as we got into it, things became more and more complex.
Mhm.
Like you said, a lot of conditionals that needed to be put in place. Not to mention that Todd spent a lot of time building that bridge from scratch.
I mean, this is was all flat pieces of plastic that he cut out and then glued together.
Wow.
I mean, it took like over 24 hours to
Total
actually-
build time,
to
right?
total
Yeah,
build
this is
time.
24.
So it wasn't something that you buy off of Amazon.
No, this was something you had to
Well,
cut
yes
out.
and no, you buy it, but then.
It's a lot of work.
Not
to produce.
pre-built.
Yeah, not
Yes.
pre-built.
Not pre-built.
It's all flat, and you know, as you can tell, there's a little bit of dimension to it now.
Yes.
It's
Very
like every
good.
piece. Oh, and the instructions are total garbage. You know, they're like the main trestle portion. You know, for
Mm.
the main triangle that supports all of the
This part.
counterweights and everything. This
Yeah.
portion right here. The instructions were completely off. They suggested that there was gonna be like pins that were available, and they all ended up matching in completely the opposite way. You know, there are 4 pieces to it, and it's supposed to be 2 pieces each, and they're all reversed in order to make it work. So I ended up having to do a lot of alteration to just that piece. It was like 4 hours just to get that thing right. So there was a lot of carving and gluing and fixing and all sorts of stuff, and the instructions are very unhelpful.
How many
What's
people
supposed
worked
to
on the
happen.
ladder?
The
How many
ladder-
people worked on the ladder?
Ladder logic?
The ladder logic.
We all kind of did a little bit in the beginning, but Tim took point on that. That's we all, you know, that's one of the things we found with having a team building this together was finding the strong suits between the 3 of us and letting that person, run with that.
Yes.
And Tim's happened to be the programming side, and so he did a pretty fantastic job.
Okay. And the, all the wiring that's so neatly managed, it's not a rat's nest, it's, it really is beautifully
Yeah,
managed, you know?
So I did a lot of well, Todd and Tim did a lot of the hard wiring from component to component. And then after their hard work, I went and undid it and made it look pretty, but come to find out, some wires got crossed and put into opposite places, so that's troubleshooting and problem solving comes into play there. So we had to then go back. We had a fully functional train, and then we did not after I made it look pretty. So it looked pretty, but didn't work.
Now it looks pretty and it does work.
And it does work, yeah.
All right, all right. So what was the best learning point from this entire exercise?
Organization.
Planning, organization, time management.
Time management, organization, planning.
We found alternative ways to solve some of our problems. I myself had ordered the wrong type of or wrong style of photo eyes for this type of controller.
Mhm.
I know you had talked about that in class, and so I had to go look online to figure out how to make that happen. Again, yes, and also like I said, alternative ways that we were having issues with our basic start command without you latching everything inside the program. We wanted to do like kind of like a one-touch system.
Which it ended up to be.
Yeah. Yeah.
And then component placement was something that we had to, play around with. Was once we got everything built and in place, where we originally thought things might fit well, wouldn't. So then fabricating brackets and mounting points creatively using heat shrink wire to make a bigger tab for your limit switches. Just having to improvise just to make things work.
Beautiful work. Questions from the audience?
Yeah, I've a couple of questions. How did the train know how far to go? Like, and then it reversed back about the same distance?
It knew how far to go by this proximity switch at the very far end.
Okay.
Once it saw that, we told it in the program to stop, and then it stopped, and then again we had to wait for the bridge to come down. Then it had an immediate reverse command to go back home.
Okay.
And what's your second question? Sorry.
My second question is, how does the Arduino play in all this?
That would be a Todd.
That's a
Okay, so the Arduino is just handling the crossing arms. It was a want to have rather than a need to have, so I banged that out in about 4 hours, building all the hardware to plug out all the couple of servos in and get the Arduino mounted and the power supply and all that stuff in this little box right over here. In retrospect, I probably should have put more signal buffer on it. That's why the arms wave a little bit. It's running off of one of the contactor points, so it should just come down when the contactor's closed, but it loses some of that signal sometimes, and it kind of waves back and forth. So in retrospect, I should have put more of a timer and some signal dampening into the programming, but it was a rush job.
Right.
It's way more interesting watching it go back and forth like a windshield wiper.
Well, thank you. Yes, that's intended.
We never see that at the real crossing where the thing goes up and down like a windshield wiper.
And they should fix that.
Yes, darn. Any other questions from the audience? Okay, let's give them a hand. Project well done.